All right, so this begins lecture number 1. Just to be clear, at this point, you should have enough knowledge where you understand what molarity is, you understand about solutions, just the basics, concentrated versus dilute, and everything dealing with that. Also, molarity, let's keep this in mind. Whenever we deal with molarity, it's always going to be moles per liter. It's moles of solute per liter, or liters of solvent. And so, just to be clear, we include that little tiny bit of solute in the volume of solvent. So really, it's moles of solute divided by liters of solution. So to kind of put this into perspective, if I'm talking about salt water, the solute would be the salt, and the solvent would be the water. So now let's take this idea to another step. So today I'm going to introduce you to a new topic, and that is how to do a dilution. So let's say I start you with a really concentrated solution of salt water, and I want you to make a much less salty version of that salt water. So let's put some numbers to it. We're going to deal with molarity, but let's just make sure we understand this first. M1V1 equals M2V2. I want to be clear about this. Capital M is molarity, as you probably expected it to be. It is not mass. So this we'll consider to be our stock solution, M1, and then that will be the volume that goes along with it. M2 and V2 represent the concentration and the volume of this new solution, this less salty solution that we want to create. So how does this all play out? Just as stated before, M1 will be the stock solution. And typically stock solutions, you could make one yourself, or a professor or a teacher could provide you with one and say, okay, here's your stock solution. Now you need to create a new solution that is less concentrated. So here's how this goes. In this problem, you have a stock solution of copper chloride. If you remember, it's kind of that really pretty bluish green color. And this copper chloride is going to be 2.5 molar. So that's the concentration. You need 250 milliliters of a 0.5 molar solution. So the question is, how much of this little tiny bit of the original solution do you need in order to create the new solution? Let's go through this step by step. As always, I want you to label everything. I want you to figure out what's the unknown, what were you given, and then let's figure out where to plug things in. So, step 1. In this case, what do I know? I know that 2.5 molar was the stock solution, and we're always going to assume that the stock solution is going to be number 1. So in this case, there's my concentration, and that will just plug into M1. So the first thing is 2.5 molar for stock solution number 1. The volume, that's what we don't know. We're actually trying to determine the volume of stock solution. I don't know how much of this we need, but we're going to find out soon enough. So for that, just like always, I'm going to put my variable, V1. Next, now we're going to go to the solution that I want to create. This new solution is going to have 0.5 molars, our concentration, and we want to have 250 milliliters. So let's deal with the concentration first. So in this case, it's 0.5 molar, which as we hopefully remember is moles per liter. Next, the question is now, can I plug in 250 milliliters as is, or do I have to convert to liters? To be honest with you, you can do either one. It does not matter because it's all going to cancel. I'll show that to you right now. So for me, why convert to liters if I want to just keep it in milliliters? So I'm going to keep it as is. So now 250 milliliters fits in. Last, just solving for V1. So in this case, this will clean this side up. Half of 250 is 125. And like always, I always bug you about, let's keep track of units. So let's keep track of the units. Instead of writing moles per liter and worrying about that canceling, I'm just going to keep it as molarity. So molarity times milliliters. On the other side, can't clean up anything yet, so I'm just going to bring it back down. So 2.5 molar times my volume. And then finally, you know what to do from here. I'm just going to get V1 by itself, divide both sides by 2.5. And this is what I want you to see. The molarity is going to cancel, and I'm going to be left with milliliters. So again, dividing both sides by 2.5 molar. Molarity cancels. Everything cancels over here. And I'm left with my volume in milliliters, just as I'd expect. So final answer, 125 divided by 2.5 comes out to be, in this case, 50 milliliters. Let's go back and check sig figs. I'm looking at 2 sig figs. I only see 2 here because the 0 doesn't count, no decimal. And I see just 1 sig fig there. So really at the end, instead of 50 with a decimal, I'm just going to put 50 milliliters. And that follows with my sig figs. So final answer would be 50 milliliters of that stock solution. And hopefully this does make sense, because I'm trying to create a larger amount of a less concentrated solution, a dilute solution. So, am I going to use a ton of that really concentrated stuff? No, I'm just going to use a little tiny bit. So I always want you to check mathematically, does that question make sense? And I think if these questions in the algebra make sense to you, when we get into the lab next week, you should have no problem at all. So now let's take this step just a little bit beyond where we are now. Let's kind of tie in some conversions and some stoichiometry. So next problem. Now I want you to prepare a stock solution. And we are going to do this as well. A little bit more complicated, but it's the same idea. Let's figure out what we have. So in this one, I'm looking through, and I have a stock solution of silver nitrate. And they gave us a concentration. But we don't know how much we actually need of the silver nitrate to create this concentration. So that's what I'm shooting for. So first things first, whenever I see molarity, I always want to turn it into moles per liter so that I know exactly what I'm working with. So let's keep that in mind, because that's going to come up. Now, the deal is, I have this volumetric glassware that measures to 250 milliliters only. So I can't just create a liter's worth of it. I can only make a quarter of a liter, 250 milliliters. So let's go through, let's figure out how many grams. I'm going to start with what I'm given. In this case, I'm given 250 milliliters, and I'm given the concentration I'm looking for. So I also have 1.0 molar, but really, I want us to get into the habit of writing that as moles per liter, because that is the same thing, and that is going to let us convert. So, step one, starting with this, and I'm going to use my concentration to get to moles. Only issue is, I'm in milliliters, which is a quick fix. I just have to get to liters first. So I can divide by 1,000, remove that decimal place 3 times. I'm just going to move the decimal. So I'm starting with 0.250 liters of this solution. I'm going to use my concentration now to get to moles. And this is an easy one. It's just 1 mole per 1 liter. So 1.0 moles of solution per 1 liter. Now, this is really of silver nitrate. So I'm going to attach that on so that we have that all squared away as well. So it's really 1 mole of silver nitrate per 1 liter of solution. Last thing, the question doesn't ask for moles. I wish it did, but it's not that simple. It's asking for grams. So let's go ahead and turn it into grams. And if at any point, if you feel like this is a bit redundant, feel free to speed along and jump right to the answer. Obviously, you want to pause this ahead of time, work it out, and then go through it. So let's see what we've got. I cheated. I've already looked it up. Molar mass of silver nitrate is 169.88 grams per 1 mole. My moles cancel. I'm left in grams. And then finally, when I solve this all out, it turns out to be 42.47 grams. Let's cut this down to size now and let's do sig figs. In this case, I'm limited by 2 sig figs and 2 sig figs. So let's go and round this off to 42. Now with the cost of silver nowadays, 42 grams, that would cost a ton of money, so we wouldn't actually ask you to do this in a lab. But if we had the money and the resources and the supplies, and I said, I need you to create 250 milliliters of a 1 molar solution, and all I gave you was an electronic balance and a big bottle of silver nitrate, you would be able to calculate and determine if I take 42 grams of that silver nitrate, put it into a beaker or into a volumetric piece of glassware, and fill it up to 250 milliliters, I would have exactly 1.0 molar concentration for my solution. So there's the next problem. Last thing, I want to take this and let's call this our stock solution now. So I've created a new solution and I want to now make a less concentrated version, a dilute version of this. So last thing, we're going to take that answer and we're going to go ahead and actually determine something else. So now, how many milliliters of this new stock solution, and don't forget that it's 1.0 moles per liter, how many milliliters of that stock solution is required to create 100 milliliters of a second solution? And this time, it's going to be 1/10 of that original concentration. It is just like the last problem, so if you feel like you just want to skip forward to the answer, totally fine. I'm going to go and show all the work for those that would like to see it step by step. My stock solution, my concentration was 1.0 molar. And that's making the assumption that you made your stock solution correct and that it is what it is. So now 1.0 molar. Next, just like the last problem, I need to figure out how many milliliters or liters of this solution I need. So that's going to be my V1. Finally, I'm trying to create a 0.10 molar solution, so 1/10 of what we originally had. And this matters. I want 100.0 milliliters of it. All right, so there's my setup, and now it just solves the exact same way as before. 1/10 of 100 is 10, and let's keep the units. Molarity times milliliters. And this side, it just cancels out. Shouldn't say cancels, but reduces. So we have 1.0 molar times V1. Notice, I'm going to skip one step, just kind of get us going. 1 molar, 10 molar, the molarities cancel. I'm left with milliliters. My V1 is 10 milliliters of that stock solution. So if you understand the math behind this, when we get into the lab, when we actually are presented with actual volumetric class, actual milliliters of solution, actual grams, and you have to determine the stock solution on your own, go right back to these examples and you shouldn't have a problem. To be clear, in the lab we're going to do two things. We're going to create a stock solution, just like in the previous problem, and we're then going to create a dilution off of this, and if time permits, we'll do multiple dilutions. So if you have any questions, please make sure that you go back. The parts that didn't make sense, write down questions, and that will be the beginning of class tomorrow.